the work that I already gave you was to identify the quantities in each of those formula and to identify any constants. We're going to look at this, we're going to look at that in a moment, but I'm going to start here in the log tables, page 44. So pause the video, get out your log tables and do this with me. On page 44, we start with the SI base units. Not really important for what we're doing, but 44 seems to be the start of the physics section of the log tables. If we go to 45, we have the list of prefixes. So our prefixes normally go up in threes, so let's go to that one. 10 to the 3 is kilo, 10 to the 6 is mega, 10 to the 9 is giga, 10 to the 12 tera, 10 to the 15 peta. 10 to the minus 3, milli, 10 to the minus 6, micro, 10 to the minus 9, nano, 10 to the minus 12, pico, minus 15, femto. So these are just for reference. And then we've got the list of fundamental physical constants. Now we're in the mechanics section, and if you look in this syllabus, we had a G there. G stands for the gravitational constant, and that's the value of it. 6.6742 by 10 to the minus 11 meters cubed per kilogram per second squared. So that's the G value that will be in the Newton's law of gravitational formula, and that's the value you need to use when you're subbing it in and calculating a value for the force, the mass, or the distance. None of the rest of them are related to mechanics. Likewise here, look, several values. We saw the permittivity of free space previously. We'll see Planck's constant. We'll see a few others. Look, speed of light in a vacuum, but none of the rest apply to us right now. Page 48, 49 are particle physics, and now we get on to the mechanics section. And I'll go through a few of these pages, right? So the first one on page 50, this formula F is equal to ma. F is the force, m is the mass, a is the acceleration. And this basically says forces cause masses to accelerate. These four formula, we've done the first three. I ignored the last one. The last one is a derivation of two of those formula. You only need the first three. But you know that they're in the mechanics section, and these first four formula are useful to us. The next lot are not useful to us in physics. So let's go to the next page. You will have come across momentum, mass by velocity. That's in applied maths, not in the physics course. That's the principle of conservation of momentum. Next one is in applied maths, not physics. These we'll do eventually, but not relevant to us. These ones for applied maths and maths only. We keep going. These ones for applied maths. These for applied maths and physics. Physics, applied maths, and brings me to these. So we've done the energy, the work, energy, and power chapters already, so that's where they are. But if we go on to page 56, we have these formula here, which are for gravitation. So we know the topic we're dealing with is gravity. This is the gravitational page of the log tables, page 56. The first one is Newton's law of gravitation, and to define that you can state that formula, and you can state that F is the force, G is the gravitational constant, M1 and M2 are the masses of the two bodies that are attracting each other, and D is the distance between the center of those two bodies that are attracting each other. So Newton's law, when you're looking for a force, you use that formula. Okay, moving to the third one, the acceleration due to gravity formula. Acceleration due to gravity is G, is equal to the gravitational constant by the mass of the planet all over how far you are away from the center of the planet squared. All right, these are the two that we'll use primarily in this topic. The other one is weight as mass by acceleration due to gravity. That'll pop up, and then that's this one rearranged. We deal with this one at a later date. And that's it.